Hey guys, got a few questions here to work through from exercise 21D and 21E.1. So I'll give you a hand with them and see how we go. The first one, considering the derivative of x squared take x all cubed, find the integral of 2x take 1, x squared take x all squared. Let's do what they said and consider this derivative. If we did that, we'd have to use the chain rule. 3 brackets x squared take x to the power of 2 multiplied by the derivative of the inside, which is 2x take 1. If we compare that to what they're asking us to do, we've got almost the same thing, except we've got this pesky little 3 in front. So in order to make that work better, now my pen isn't aligned here, so it's a little bit tricky to get the thing that I'm after, but I'll keep working on it. If I had a 3 in front, I would then know the integral of this is just what I just differentiated. That would work. So in order to do that, I've just got to put a 1/3 in front of it. That just means my final answer is going to be 1/3 times x squared take x all to the power of 3 plus c, because of course we've got to have our constant of integration there. So that's the way they're encouraging you to do it. You can just get here and say, oh look, I've got everything I want except for I don't really want that 3, so if I just had 1/3 in front of this, then it would have worked, and you could put the 1/3 in that way. It doesn't really matter. So that one's not too bad. Let's go on to the next one. The next one is 21D, question 10. It's asking for a proof. It's not anything really complicated here. What it's basically based upon is if f of x, if the derivative of f dash x equals f of x, and the derivative of g dash of capital G of x, g dash of x equals g of x, or I could write that as the integrals, it doesn't really matter. The integral of the little one equals a capital 1, standard notation. Either way, I've got the left hand side is going to equal, actually I should start with the right hand side. Right hand side is going to equal f of x plus some sort of constant, and the integral of g of x is going to be capital G of x plus another constant, which is just going to be f of x plus g of x plus, I could combine those constants into a third constant, wouldn't really matter, and that would just equal the integral of f of x plus g of x dx, which equals the left hand side. You're not going to get one exactly like that. That's just a little bit of playing around. It's not so important, that one. The next one's a bit more important. I want to make sure we're all able to do this, so let's see how we go with this one. Here I've got 1 over x root x plus 4 on x dx. Yep, that's what we've got. So we're just going to make that look a little bit nicer first. That's the same as the integral of 1 over x to the 3 on 2 plus 4 over x is 4 x to the negative 1 dx. Let's just again make that look a little bit nice by writing this 1 over x to the 3 on 2 as x to the negative 3 on 2 plus 4 x to the negative 1 dx. Now this one's easy enough. Add 1 to the power, divide by the new power, so it's going to be x to the negative 1/2 divided by negative 1/2. You can make that multiplied by negative 2 straight away if you want, if you're happy with that. I'm just going to do it in 2 steps. This one, the 4 over x, or 4x to the negative 1, if I tried adding 1 to the power and dividing by the new power, that's that thing where you divide by 0. That's your reminder that when you're just integrating 1 over x, it's ln x. So this one's just going to be plus 4 natural log of x. Now, when you're integrating, make sure you put in that's the absolute value, because we can only find the logs of positive numbers. Plus c goes on the end here. Tidy up this bit. I've got divided by negative 1/2 is multiplying by negative 2, so it's negative 2 over root x if you like, or you can just leave it as x to the negative 1/2 plus 4 natural log of x plus c. And we're done there. Finally, it was D that we were after here in question 3. These are from 21E.1. So question 3, 1 minus 4x over x root x. Ugly denominator. Let's sort that out again. This is going to be integral of 1 over x root x, and that's x to the power of 1. Root x is x to the power of a half. 1 plus a half, 3 over 2. So that's 1 over x to the 3 on 2. Minus, if I do the 4x over x root x, you can see the x's would cancel. And that's 4 over root x. 4 divided by x to the half is just 4x to the negative a half dx. So this is x to the negative 3 on 2, add 1 to the power divided by the new power. Is that the one we just did before? It is, so that's pretty easy. Negative 2 x to the negative 1 half. Here, add 1 to the power divided by the new power, so it's going to be x to the half, divided by half, multiplying by 2, so we're going to have negative 8 x to the half, or negative 8 root x, plus c. And we're done. That's all there is to it. Hope that helps. Good luck with your studying. Keep the questions coming. Cheers.